With PETG filaments, my print temperature is usually around 250 degrees Celsius. But with the carbon fiber version, can I go higher? Can I print at 270, 290 degrees Celsius? Will I get better layer adhesion? I don't know, let's find out. Welcome to another material testing video, but a little bit different. Carbon fibers in filaments helps with the printability, stiffness along the X and Y direction, temperature resistance, but usually they will make the layer adhesion a little bit weaker. Now recently I tested everyone PETG versus carbon fiber PETG, and there the layer adhesion was very similar. So I was wondering, since the fibers helps with the printability, can I go much higher with the print temperature? Can I print at 270 or 290 degrees Celsius? What will be the layer adhesion in that case? And this is what I want to investigate in this video. And this is not a sponsor video. Everyone sent me this filament for the testing, but that review already happened, so they don't even know that I will do this video. And also I check my summary table for my Patreon supporters, and I just do a filtering. First I selected all PETG filaments reinforced with carbon fibers. And yes, this filament has the best layer adhesion, so this is the only reason why I am using this filament. This is my experimental plan. First I will give a serious drying to this filament, and maybe I will even measure the weight to be sure that it is completely dry. And after this I will print a temperature tower, but from 250 up to 290 degrees Celsius. And if everything will be okay with the temperature tower, then I will print some test objects for the layer adhesion on 250, 270 and 290 degrees Celsius. Small change in the plan. Beside the Everyone PETG carbon fiber filament, I will include the Timori PETG carbon fiber filament too, because I did this testing in the meantime and it also has a great layer adhesion. But before the drying, I will measure them now. And this is Everyone. And I will measure them every 1 hour until I can see any bigger change in the weight. And I'm drying them on 70 degrees Celsius because this is a little bit higher than the recommended drying temperature for the PETG filament. But this is carbon fiber PETG, and I know that this is not much for this filament, especially in this dryer which rotates the spool during the drying. Measuring after 1 hour. Tilbury looks much drier, but I will continue with drying. This is measuring after 4 hours. I can see Tilbury is ready for the printing. Everyone not yet, I will continue with the drying. I think this will be the last measuring. And now it is in similar dry stage like the Timori filament. Quickly just to analyze the drying, and I can see that I started with the Timori filament printing a little bit too early, because I was just watching the difference between two measurings, but I didn't analyze the graph only now, and until the graph is almost linear, in that case it is worth to continue with the drying because I can still remove quite big amount of the moisture. For example, we can see this with the Everyone filament. Here I was drying 7 hours, and this was now closer to that horizontal line. Of course it was still far, so even here I could continue with the drying. And this method I explained earlier, for example, with the PETG-CF filament drying. The printing will be on X1 carbon, but the doors will be opened, and I can see 3 possible problems here. The first one is the heat creep. This means that the filament melts in the cold zone and wouldn't dare to go so high with the print temperatures with the regular PETG filament. The second possible problem is too strong bed adhesion. So even when I will print with 290 degrees Celsius, the first layer temperature will be only 260 or maybe 270 degrees Celsius to avoid too strong adhesion to the bed. And the third possible problem is that if I don't have enough part cooling, in that case the material may curls up and the nozzle may hit the objects and remove from the bed surface. Here you can see one example what happens if the part cooling is not enough. The temperature tower will be from 260 up to 290 degrees Celsius. Only I don't have the elements with those numbers, but the printing temperature will be correct. And the flow rate will be 12 cubic millimeters per second. This is the default part cooling. With Everyone I was going slower in that review video, with Timori faster, but here it will be 12 in both cases. And this is the finishing of the Timori temperature tower. This is the last element, and I recorded here the finish of the printing. And this is the Everyone, also printing the last element. Completely same G code I used here. two temperature towers, and the bridging and the stringing is completely equal. I mean, no stringing, so they look nice on any element. Only on the overhangs I can see some difference. For example, on every one, these 60-degree overhangs didn't come out so perfectly on two top elements, but my test objects are below 45-degree angles, so it should be fine. And these are my regular layer adhesion test objects. 4x4mm is smallest cross-section area. And beside the test objects, I have this D6 dice. With this, I give to layer more time to cool down. You don't have to slow down. And here you can see the default part cooling during the printing was 40%. Side by side, 3 time lapses with the tin filaments. And now this is the area one. And in all 6 cases, perfect printing every time. This is the results. Timori test objects 250, 270, 290 degrees Celsius, and area 1 250, 270, 290 degrees Celsius. And visually I cannot see any difference between them. It's time for the testing, and you will see the average values on the screen, and later I will analyze them. I will show the graph later, but if you follow the numbers you can see strange behavior, especially on 290 degrees Celsius. So I decided to have a few more printings, and for both materials I will print test objects on 230 degrees Celsius and from Timori on 285, just to confirm something. Now let's analyze the results, and on the left side of this graph we can see area 1 filaments, on the right side we can see Timori test objects printed on different temperatures. And this is the recommended temperature range. And with area 1 filaments we can see that it is worth to go higher on that recommended temperature range, maybe a little bit above it. With Timori, basically we can have nice printings on any temperature inside this range. But in both cases it is not worth to go much higher. For example, printing on 290 degrees Celsius. In my cases I got a weaker layer adhesion, and we can experience some problems here, for example uglier top surface or similar. I prepared here one more data, and these two lines are from the review videos of these filaments, and these two are from this video. Let's analyze the area one, because we have the same print temperatures. What is changed the max flow and the drying, and I have much better layer adhesion. Is this only the effect of this bigger drying, or changing the flow rate? But I thought that increasing the flow would actually reduce the layer adhesion, or maybe increasing the flow, less time to cool down for the filament, and we will have better layer adhesion. Because that would explain this, why a little bit smaller flow rate resulted very similar layer adhesion, even if I printed on 270 degrees Celsius. I think this is something, again, what I have to investigate a little bit better. Not exactly what I expected, especially that printing on 290 degrees Celsius. I'm not sure what resulted the weaker layer adhesion there, but the difference is not big. Maybe it's just inaccuracy in measuring, but I got very similar results with both materials. But anyway, good news is that we have usually that recommended temperature range, and I always recommend to go higher on that recommended temperature range. In that case, you will have good layer adhesion, but still good quality. Use that lower only in case if you have some limitation by the printer or you have some issues with the print quality. And these are really good filaments. I mean, this break load about 60 kilograms. I checked that summary table from my Petra supporters, and the average tensile strength for PETG filament, which is printed in horizontal position, is 77 kilograms. This is great layer adhesion, and don't forget these are carbon fiber filaments, and actually with them we don't have that weakness or just very minimally along the z-axis. And don't worry what we are doing with all these dices. These are giveaway for my students, and I really like gifts, 3D printed objects. You know, those who don't have a 3D printer, they really appreciate these kind of gifts. And don't forget that if you like this kind of videos, subscribe and click that notification bell button too, because in most cases, from some reason, my videos are not recommended by YouTube algorithm, only to those who enable that all notifications. That would be it from my side. Waiting for your suggestions and comments. Thank you for watching and happy printing.